Welcome to this Maths Made Easy video on infinite series binomial expansions. To start with, let's take a look at the infinite binomial expansion. Now let's consider writing the binomial coefficients in a different way. So let's say we write this as n choose 0. Well, using our formula, that would simply give us 1. If we take n choose 1, here this would give us, again, just using our formula, n over 1. If we have n choose 2, that would simply give us n times n minus 1 over 1 times 2. And if we do this one more time, just so we can see the pattern that's forming here, so if we have n choose 3, well, we would write that as n times n minus 1 times n minus 2. Okay, it's all going to be over 1 times 2 times 3. And hopefully you can see the clear pattern that has emerged. And what we can see here, if we generalize this, so if we say n choose r, what we would obtain here is n times n minus 1 times n minus 2, and this extends here up to n minus r plus 1. Okay, so that's our numerator. And then don't forget, for our denominator here, this is going to be 1 times by 2 times by 3, and this will extend up to finally times by r there. Okay, and we can use this pattern instead of actual binomial coefficients to write an infinite expansion for 1 plus ax to the power of n. Okay, when n is not a positive whole number there, so n is not a positive integer. And if we write this expansion in full, then what we can see here is 1 plus ax to the n can be expressed as 1 plus n times ax plus n times n minus 1 over 1 times 2 times a squared x squared. And this extends now here all the way up to n times n minus 1. And we can see this keeps going on here to n minus r plus 1. And our denominator here will be 1 times 2 times 3. And again, this extends up to r. And finally, we times this by a to the r times x to the r, and so on. Okay. So that gives us everything we need there for the infinite binomial expansion. Let's just make a quick note here on factorization. Now, the formula that we've just used only worked for expressions of the form 1 plus ax to the power of n. So how would we expand, for example, ax plus b to the power of n? Well, in that case here, we'd write ax plus b to the power of n as b to the power of n 1 plus a over b x here, and we'd write this all to the power of n there. Okay, and then we'd simply just use our formula on this expression here on 1 plus a over b x to the power of n, and then we just multiply our final answer by b to the n there. Okay, so that gives everything we need there for factorization. Let's take a look now at the validity of the binomial expansion. Now, if we try this out here, so a plus bx to the power of n is never infinite in value, but an infinite expansion might be unless each term is smaller than the last. Now, to prevent this explosion to infinity, we can only work with certain values of x. Specifically, the binomial expansion of ax plus b to the power of n here is only valid, so we just write this out here just so we can make a note of it. This is only valid for the following expression here. Okay, so that's what we need there for the validity of the binomial expansion. And we just note here that if n is an integer, then we do not need to worry about this, because we get a finite number of terms in the binomial expansion, so it can never have an infinite value, and as a result will always be valid there. Okay, so that gives us everything we need there for the validity of the binomial expansion. And finally, let's take a look now at combinations of expansions. Now sometimes we will be asked to expand something that contains more than one binomial term. And we do this by treating each binomial term individually, and then we would just handle them all together at the very end. Now let's just take a look at this example here, where we're asked to find the first three terms of the following expansion. Now what we do here is we just treat these individually. So if we start with the 1 plus 2x to the minus 1, and we'll do that in red. So here, considering the 1 plus 2x to the minus 1, well, all I simply need here is my expansion for 1 plus 2x to the minus 1. So all I'm going to get here is 1 minus 2x plus minus 1 times minus 2 all over 1 times 2, and we simply times this by 2 squared and then times that by x squared there. Okay, and that gives us the first three terms. We don't need to worry about any more, but obviously this would carry on here. Okay, so if we simplify here, what I get then is 1 minus 2x, and simplifying this part here, well, that's going to be minus 1 times minus 2, giving us 2. We divide that by 2, so it gives us 1, and then we times that by 2 squared, and times that by x squared. So that would just simply give us 4x squared there. Okay? And obviously, like we just said, that expansion would carry on, but all we're concerned about is the first three terms. And now if we consider the expansion of 1 minus 3x here to the power of a half, and again, let's do this in blue pen. So this is 1 minus 3x to the power of a half. So the expansion here is going to be 1 plus a half of minus 3 times by x plus minus a half. Oh, sorry, a half there. So if I just go to that minus, so it's going to be a half times by minus a half there. Okay, so, oops, we'll go back to blue pen here. Make sure we don't make that mistake. So minus a half here. We divide this by 1 times by 2. And then we times this by minus 3 squared and times it by x squared. And again, this just gives us the first three terms, but obviously this would carry on. Now if we simplify each term here where we can, that's going to give us 1 minus 3 over 2x. And here this would simply give us, if we simplify this correctly, minus 9 over 8 x squared there. Okay, so that gives us the first three terms there. So what we've got is the first three terms of our expansions individually. What we need to do now is consider this as a product. So considering this as a product now, we can write this as 1 plus 2x to the minus 1 times 1 minus 3x to the power of a half. And now we're just going to consider this as a product. So like we said, this would give us 1 minus 2x plus 4x squared times by now this expression here. That's our expansion for 1 minus 3x to the power of a half. So 1 minus 3 over 2x minus 9 over 8x squared. Okay. So finally here, all we want is the first three terms of this product. So in that case, what I'm going to do now is I'm going to take this 1 and we would times that by all three terms here in this second bracket. We'd then take the minus 2x, but we'd only times it by the first two terms. Remember, we only want the first three terms. So in that case, we take the minus 2x and we times it by the first two terms. And then finally, if we take the 4x squared here, we would only times that by the first term. And all we need to do then is simplify where appropriate. So writing that out in full here, what we obtain is 1 times 1 minus 3 over 2x times minus 9 over 8x squared. So what we've got just to start with is 1 times by our second bracket in full. And now we minus 2x. We take the minus 2x here from our first bracket, and we only times it by the first two terms. Okay, 1 minus 3 over 2x. Okay, now obviously these expansions would carry on, but like we said, we're only concerned about the first three terms. And finally here, we're going to take our 4x squared, and we're going to times it by the first term, which is 1. Okay, so here now, all we need to do is simplify where appropriate. And to do that, we just need to expand all brackets here where we can. So expanding this first bracket here with this 1, I'm going to get 1 minus 3 over 2x minus 9 over 8x squared. Okay, so that's our first term. We've now got that's our first part here. We've got minus 2x times by this bracket, so that's going to give me minus 2x And in that case, I'm going to get plus 3x squared. I get plus 3x squared there. And finally, we get a plus 4x squared there. Now to finish, all we need to do here now is collect like terms. So we've just got this 1 here at the front, and we can't do anything further with that, so we've just got a 1. Collecting my x terms together now, I get minus 7 over 2x. Okay, so minus 3 over 2x minus 2x gives us minus 7 over 2x there. And finally, dealing with the x squareds now, I've got minus 9 over 8x squared plus 3x squared plus 4x squared. And in total, that gives us 47 over 8 x squared there. Okay, and clearly that would carry on, but like I said, we're only concerned about the first 3 terms there. Okay, so that gives us the solution to our example, and that gives us everything we need there, combinations of expansions, and that concludes this Maths Made Easy video on infinite series binomial expansions.